Okay. Good afternoon. Welcome to yeah, you can start. So, welcome to the Monsoon seminar, and we are celebrating Azadi Ka Amrit Mahotsav. This is a part of our celebration, the seminar. We have several invitees. Dr. Sanap from IMD, Professor P.N. Sen, Dr. Kiplani, Dr. Rup Kumar. We welcome all of you, and we thank you for being with us. And today we have online with us Professor P.N. Goswami from Cotton University. Welcome you, sir, and nice to see you a long time.
Thank you. Thank you.
So with this, let us start our presentation. First presentation is by Dr. Sanap from IMD. He will talk about synoptic features. So Sanap, please.
Good afternoon. I'm SD Sanap from IMD Pune. I'll be talking about synoptic features of July 2022. So outline of my talk goes like this. I will be talking on chart analysis for week ending 6, 13, 20th and 17th July. Then I will be talking about a synoptic condition associated with the flash floods in Pakistan, heavy rainfall activity over Gujarat, MP, Rajasthan, Saurashtra, Kutch and adjoining regions. And then I will be talking about heat wave in Europe and heavy rainfall events over the northwest Indo-Pakistan region. And then at the end, I will be talking about the present synoptic conditions and model guidance for next 5 days. So we
cannot see the screen. We cannot see your screen. The online people cannot see. I can see you, but not the screen.
Okay.
Now we can see.
Okay.
Okay, that's good.
Yeah. So I was just telling sir the outline of my talk is like this. So chart analysis for the last 4 weeks I'll be talking about, and then a synoptic condition associated with the flash floods in Pakistan and heavy rainfall for Gujarat, MP, Rajasthan, Saurashtra, Kutch and adjoining regions during 6 to 8 July. Then heat wave in Europe and heavy rainfall events over northwest Indo-Pakistan region. I'll be talking about that also. And at the end, I will be talking on present synoptic conditions and model guidance for next 5 days. So the synoptic conditions or the chief features for the week ending 6th July were like this. The southwest monsoon covered entire country on 2nd July and against its normal date on 8th July. And then establishment of the monsoon trough was there and its southward tilt was also seen. Then formation of this low pressure area over the coastal Odisha and adjoining region was there, and its intensification into well-marked low pressure area after moving north-northwestward and then south-westward over the South Pakistan, and associated rainfall activity will also be discussed. Was there, and then rainfall during during this week was weak over the northeast Indian region, which was very high in June. And if you see the monsoon trough is established and over the Indian region, and then monsoon also setting over the Indian region. And Somali jet speed index, if you look at, it was during the first week of July, it was its values were higher than the climatological values. And if you look at the MJO was in the phase 2 and phase 3, and which actually helped in revival of the monsoon or the monsoon activity over the Indian region. So if you look at the surface charts for second, there was a monsoon trough was established, and there was a formation of the low pressure area over the Odisha and adjoining region, and then its northwestward movement. Its northwestward movement was also also seen, and associated rainfall activity was there, and then this low pressure area moved northwestward, and then later on its movement was south westward, and then it intensified into a well-marked low pressure area over the North Arabian Sea and adjoining South Pakistan region. If you look at the rainfall percentage departure for the week ending 6th July, we can see the movement of the low pressure area and monsoon trough, the rainfall percentage departure was excess or large excess over the region, and subdivisions like Jharkhand, Bihar, Gangetic West Bengal, and then Assam or Himachal Pradesh and J&K also, there it was in the deficient category. And rainfall greater than 100 millimeter accumulative rainfall for the 7 days. You can see the movement of the low pressure area along that and also western coast region. The values rainfall values greater than 100 millimeter was there. If you look at the weekly composite analysis for the week ending 6th July, you can see that the establishment of the monsoon trough and its extension up to 1.5 kilometer, and there was a cyclonic circulation associated with the low pressure area, and its southward tilt with height can be seen at 500 HP, and southern latitudes indicating highest wind speed at 100 HP was around 80 knots. Then I'll talk about the heavy rainfall and flash floods for the Pakistan and South Pakistan adjoining region. There was a well-marked low pressure area over the North Arabian Sea and adjoining Saurashtra Kutch and adjoining regions. We can see that the highest cloud amount was over that region, and satellite estimated rainfall also indicating the heavy rainfall over the region. So and yeah, we can see the well-marked low pressure area over the region. And if you look at the other synoptic conditions on that day, there was a cyclonic circulation over the well-marked low pressure area was already there, and then there was a cyclonic circulation over the Odisha and adjoining region extending up to mid-tropospheric level. East-west shear zone at 3.1 kilometer was also there. And if you look at the GFS analysis on that day, there was a well-marked low pressure area and associated moisture supply from the Arabian Sea, as well as upper level, lower to upper lower to middle troposphere. There was a moisture transfer was also from the Bay of Bengal, and which resulted into the heavy rainfall activity over the region. So now I'll move on to the chart analysis for the week ending 13 July. So the four main synoptic features were there. So first was the formation of low pressure area, and it was there for like 9 to 14 July. And then monsoon trough remain active, and it was south of its normal position. And then persistence of east-west shear zone in the lower and mid-tropospheric level aligned across the northern part of the peninsular India. With southward tilt was also there, and offshore trough was also there during this week. So surface analysis, we can see that on 9th of July there was 9th of July we can see that the monsoon trough position was like this, and then on 12th it has moved further southward, and then this low pressure area got intensified into well-marked low pressure area on 12th, and it persisted on 13th, and then later on there was another well-marked low pressure area formed over this region, and very fast it intensified into a well-marked low pressure area. And we can see that the southward movement of the trough during the week. And associated rainfall activity, we can see it was mainly confined to the monsoon core zone, and the cumulative rainfall greater than 100 millimeter was also in the similar. Is also corroborative with that. And if you look at the weekly composite pictures for this week, you can see that the monsoon trough and its extension up to 1.5 kilometer, and there was cyclonic circulation associated with the low pressure area over the Odisha and adjoining region, and its southward tilt can also be seen, and Tibetan high position is at its normal position. And then now I'll talk about the chart analysis for the week ending 20th July. So these were the chief features. The previous weeks, the Wellmark low pressure area has weakened, and then it moved northwestward, and it reached over the region of Vidarbha and adjoining MP, and it gave heavy rainfall over the region. And a low pressure area over the northeast Arabian Sea and adjoining coastal areas of the Saurashtra was formed, and then it concentrated into a depression on 16th of July, and then movement of the western disturbance and its interaction with the monsoon flow was there, and which caused heavy to very heavy rainfall activity over the parts of Punjab, Haryana, and adjoining areas. And if you yeah, we can see that there was a formation of low pressure area, which then actually concentrated into a depression. There was a low pressure area. Then the earlier Wellmark low pressure area has reduced its strength, become low, and we can see that there is a movement of this low, and then this depression has reduced its intensity, and that also moved westward. And then after this week, we can see that there is a slight northward movement of the monsoon trough. And we can interestingly, we can clearly see here that the cloud mass associated with the depression and low, and then on 21st of July, when monsoon trough moved northward, the associated cloud band also moved northward. And then weekly composite per year charts also indicating the same. It's extension of the monsoon trough up to 1.5 kilometer, and the movement of the low pressure area and associated cyclonic circulation can be seen, and Tibetan high is again at its normal position. And rainfall activity also can, and associated rainfall activity we can see is along the movement of the low pressure area and cyclonic circulation, and heavy to very heavy rainfall also occurred over the monsoon core zone, and also western coast. Then I'll talk about case study of heat wave in Europe and heavy rainfall events for northwest Indo-Pakistan region. UK Met Office already declared that the earlier record of 37.1 degrees Celsius was broken, and now new record be the reason for the heat wave in Europe. We can see that there was a blocking high over European region, and it is a typical omega block. And during whenever there is a blocking like this, it actually transport the heat from the tropics to mid latitude region, and if that block is there for the longer period of time, it leads to the situation like increase in temperature as well as heat wave kind of a condition, and that was the case here. And on 19th of this is the analysis from ECMW, which actually this is geopotential height at 500 SPA, and colors are nothing but the temperature at 850 SPA. So it is clear that there was a omega kind of a block. And if you look further eastward, we can see that there is a another secondary block, which is called as a Ural-Siberian block, and which has implications to the rainfall activity with the northwest Indian region. I will just talk on that. So if you look at the GFS analysis on that day, we can see that for northwest Indo-Pakistan region, there was strong moisture supply from the Arabian Sea, and as well as there was moisture supply from Bay of Bengal also. And if you look at the 500 SPA, we see that comparatively dry and cold northwesterlies were there in the higher level at 500 SPA. So that creates the instability over the region, and which was reflected in the rainfall. We can see that on this date, 21st of July, there is strong cloud mass over the Pakistan, and from 19th, 20th, and 21st, good rainfall activity was there over the northwestern part of the region, like Haryana, Punjab, Rajasthan, etc. So here in anomaly plots also we can see that the rainfall activity over the Indian region was also there, as well as the Pakistan region. It was there. So I'll move on to the chart analysis for the week ending 27th, yesterday. So in the beginning of this week, monsoon trough moved slightly northward with formation of the formation and northward movement of the upper air cyclonic circulation and its extension up to mid-tropospheric level led to the widespread rainfall activity over the region along the monsoon trough. Actually, this upper air cyclonic circulation, which was in the Jharkhand region, which moved initially northwestward and which actually caused the rainfall activity along the monsoon trough, and then later on it actually moved further southwestward, and then there was a formation of low pressure area over the Gujarat and adjoining Rajasthan region, and then northward movement of the monsoon trough was seen day before yesterday. So we can see that as I was saying, there was a cyclonic circulation over this region, and its extension was there up to mid-tropospheric level on 23rd, say, and then 24th also it was there, but slight northward movement was there, and on 26th also it is there, and then later on there was a formation of the low pressure area, and which can be seen from surface charts. This was 23rd. There was this monsoon trough position was like this, and then movement of the what we say upper air cyclonic circulation was there, and its flow is here, and then later on there was a formation of the low pressure area which moved westward, and if you look at yesterday's position of the monsoon trough, which moved a bit northward from its earlier position. So if you see the last week's main composite picture, we see that the monsoon trough extending up to say 1.5 kilometer, and its axis was like here, and then cyclonic circulation associate. I mean that has come here in the weekly analysis, and if you see there is, I mean Tibetan high position is not clearly in the weekly maps, but it is there in the our daily maps, and then. Last week's rainfall activity mainly confined to this region. So you can see that Maharashtra, Goa, and Madhya Maharashtra subdivisions, and like South Interior Karnataka, then coastal Karnataka, and what we say Kerala. Here it was rainfall activity was mainly deficient or large deficient, and our Odisha, Jharkhand, and Gangetic. West Bengal also it was in the deficient category, and also Himachal Pradesh and Arunachal Pradesh and Assam. Mainly monsoon trough position was over this region, so rainfall activity was mainly confined to that. And if you look at Somali jet wind speed index for like today's position, it indicates that its value is less than its climatological value. And the monsoon trough also actually moved north from earlier position, and it is. And then if you look at the MGO, MGO is actually is at phase 1 right now, and it is expected to move over the equatorial Indian Ocean. And at the same time, if you look at 850 HPA GFS analysis, there are 2 twin vortices for this region, and it's like Rossby wave, equatorial Rossby wave kind of structure right now, and we are monitoring it. And there is a upper air cyclonic circulation extending up to 1.5 kilometer there. And with the help of if MJO is entering in a, I mean, it's actually forecast is indicating that it will be in the weak phase, but weak phase, and then we have this vortices also, and models are indicating that its movement will be northeastward. So if that is the case, then we can expect a revival of the monsoon after 1 week. And model guidance for next 5 days. So we actually use various models like GFS, NCEP, JMA, NEPS, GPS, NCOM, WRF for 3 days, NCOM, regional, and HMWF, and all models are in consensus that in coming 3 to 4, almost 5 days, the monsoon activity will be confined to the northern part of the region, mainly due to the northward movement of the monsoon trough, and then we can expect a revival after 1 week, maybe yes. And we also have actually MME rainfall forecast using all these models. So all models are also in consensus that the rainfall activity will be mainly confined to the northern part of the region during next 5 days. So yeah, thank you.
Thank you, Dr. Sanap, for a nice presentation. So we will take quick questions from audience.
Can I?
Yeah,
Yes.
sure.
This is enhanced synaptic activity
Yes, sir.
during the last few weeks.
Yes.
Can you attribute to some large scale forcing? See, whenever I see a lot of conventional water central India, and if the Equatorial Indian Ocean, eastern side, conventional suppressed. When I can see there was some
Right. So, sir, mainly there was a low pressure area formation over the Odisha and adjoining region. Yeah, but large scale La Nina conditions are now prevailing, and we have IOD is there, but we are, I mean, it is all models are indicating that it will be like it will be in the negative IOD conditions will be expected in coming few days, but right now it is not there. So La Nina condition maybe we can attribute to this.
So again, it is going to the big days of monsoon.
Yeah, for next 1 week at least we can expect it.
Very good.
Thank you.
Is there any question? Whether BNJ has any question?
No, not right now. Maybe we'll take up when discussion time.
Yeah. Yeah.
Mm.
Okay.
Yeah. Oh,
Yeah.
okay. We will go
Thank
to
you, Benji. Yeah. I have.
Hi, Krishna.
Hi, Benji.
Yeah.
Nice to see you.
Hello.
Yeah, thank
Yes.
you.
Yeah.
Yes. Yes, sir.
I don't have a question. I mean, more like a comment. Sanap, nice presentation, Sanap.
Thank you, sir.
Hello, can you hear me?
Yeah.
So you were showing that European heat wave and kind of teleconnection.
Yes,
So
sir.
what did you propose your conclusion
Yeah.
about the rainfall over India, Northwest India, and European heat wave? Did you see something? I thought I missed some. Did I miss something there? Or?
I'll just show you. Yes, sir. Sir, if you look at European region, there was a strong atmospheric blocking, like a typical omega kind of a block was there. And there is another omega kind of a block for Ural Siberian region, sir, here.
Okay.
Yeah, and then if you look at the lower level winds, like 925 HPA, there is a strong moisture supply from the Arabian Sea. And for in here this region, sir, so there was strong comparatively cold and dry westerlies reaching up to this region.
Yeah.
So
what is causing what? The
Yeah.
European heat wave is affecting Indian region, or Indian region is affecting? I mean, I wanted to know if
Okay,
your
sir.
thoughts on that.
Yeah. So, sir, if moisture supply is not there from the Arabian Sea, so we cannot expect such activity. So, strong moisture supply was there. That actually facilitated this event.
Yeah. See, 2003 also, July, when we had good rain over India, and also 2006, some part. I think Europe had European region had heat waves. So
Yes.
the Hoskins and other Hoskins, Enomoto, they have done some work. I don't know whether it's related to that.
I'll check, sir. Thank you.
Yeah. Okay, fine. Thank you.
Thank you, sir.
Thank you, sir.
Yeah, I would like to request Dr. Justice to start presentation.
You can use keyboard as well.
Okay. Okay. Yeah. Good afternoon to all. I'm going to talk about large-scale circulation associated with the current monsoon and oceanic features. I would like to thank my colleagues for their inputs. Let us start with June rainfall.
If you look at June rainfall, by and large, you have deficient monsoon or monsoon trough region and heavy rainfall over northeast India, and we have low rainfall over western Ghats and high rainfall over Tamil Nadu and Karnataka region. And when you come to July, if you can divide this trough into two parts, one northern part and southern part. So in July, southern parts received a lot of rainfall, and it helped to like actually monsoon to revive. And in the northern part, the deficient rainfall is just persisting even in the July. Now, what are the like external and internal factors that are actually responsible for this fact? Here, the monsoon trough was always to be the south of normal position, and we can attributing the more rainfall in the central and here, central and south India. And due to this, 5 states, starting from UP, Bihar, Jharkhand, and Yantic, West Bengal, received very low rainfall. And now, what factors are responsible to inhibit northward propagation of the monsoon trough, especially in July, is important. And what are those important, like large-scale patterns, cause this kind of rainfall pattern is also very important. Okay, when you look at OLR of June, I will talk about June first and we'll go to July next. And when you look at the tropics and June rainfall, so the northwest and southeast tilted low rainfall band is very clearly seen from Central Pacific onward. So Central Pacific to Philippines and then to Head Bay of Bengal to monsoon trough region. So this suggests that the monsoon low rainfall over the monsoon trough region is associated with like large scale circulation, not with the local phenomena. And you can see the same thing here in GPCP rainfall, and you do see that high rainfall over northeast India and central parts of China, and also over the southeast equatorial Indian Ocean. And this high rainfall can be attributed to one, La Nina, and secondly with the local SST anomalies. So now from these two slides, clearly we can say that the rainfall or reduced rainfall over the monsoon trough region is basically is not localized. It is large scale circulation related. So when you look at the composite of La Nina in June of rainfall here, so in generally June receives a lot of rainfall over the India, but in June 2022, so in La Nina case, what you see is very different pattern with high rainfall over the equatorial Indian Ocean region, and north and between we have a suppressed rainfall. And why is that? That is mainly because the ridge is sitting over the monsoon trough region, which is extending from the Central Pacific. Here, this is the SST anomalies and surface wind anomalies for June. So this extension can be clearly seen when you plot SLP anomalies from other products also, and you do see high pressure anomalies over the Bay of Bengal. And these features are very well explained here. Velocity potential of 850 HPA. You do see the divergence over the lower levels is extending all the way to Indian summer monsoon region. So this is not allowing to set the monsoon in June. And moreover, there is anticyclonic circulation associated with this high over the Bay of Bengal can be also seen. And when you look at May, here it is a May SST anomalies. So La Nina was prevailing with cold anomalies here and warm anomalies in North Pacific. It is something like PDO type pattern. But anyway, so La Nina strong negative anomalies on the equator are seen around dateline, not in the eastern equatorial Pacific region. So that is important here. And as you move on to June, these anomalies are slightly strengthened, but you see that the equatorial Central Pacific region has a cold anomalies here. Because of that, we can take it as a negative heat source, and you would expect two anticyclones like south and north. So you can see that there is one anticyclone here and another anticyclone in the south of this heat sink. And this anticyclone is just not initiated in June, so it is there from May onwards. Because you have cold anomalies here, so a clear Monsoon pattern can generate this anticyclonic circulation. As you move on to June, from May, the subtropical high moves slightly southward and intensifies northeasterlies, and the monsoon also, like northwest Pacific monsoon, East Asian monsoon, sets with that, and that is a favorable along with this easterly scale superimposed on the mean. So you can see extending easterlies towards the Bay of Bengal, and you have anticyclonic circulation. Basically, this westward extended AC has significant impact on ISM rainfall. Again, start with May. You do see anticyclonic circulation. Here I am showing monthly mean 850 HPA stream function anomalies, and vectors are wind anomalies. And you see that there is a high in May itself, which is also extended from the kind of central north and Pacific till western North Pacific. And moreover, you have strong easterlies here. They can generate anticyclone. So two together forms a nice high pressure anomalies over this region. And as you move that to June, you do see that the anticyclone is extended to Indian summer monsoon region or trough region where rainfall is very low. So there are two factors, one from the equator, one from the subtropical region, that caused the ridge to maintain there and caused for low rainfall, which is also very nicely illustrated in 200 HPA velocity potential. Here the velocity potential shows like upper level convergence is extending all the way to Indian summer monsoon region, and this contour shows the water circulation is there, but anomaly shows that water circulation is weaker. Now, how to explain rainfall patterns? So we did some work for 2020 and 2020 JJ, like June, July rainfall pattern. If you see high rainfall in East Northeast India and over southern peninsular India, and low rainfall over the monsoon trough region is resembling the pattern somewhat to the current June pattern. And you have anticyclonic circulation here is highly tied with Northwest Pacific anticyclone. When you take time series from this box and regress 850 HPA winds and moisture flux, what you see is anomalous anticyclonic circulation here and corroborated by this Northwest Pacific anticyclone. Therefore, the ACC spinning across Northwest Pacific region strengthened the moisture transport from the Bay of Bengal to Northeast India, and thus led to persistent rainfall via local orographic lifting here. And when you move to the trough region, and this trough region got low rainfall in June, that is because moisture divergence over this region. And to verify our results, so we have plotted SLP index shown in the Bay of Bengal box, say that is representation of anticyclonic circulation. And when you correlate onto the monsoon, by and large, you do see the pattern is similar to that of June, indicating that this extended anticyclonic circulation is very important and determine the large scale these rainfall patterns for India. And when it comes to decreasing rainfall over parts of monsoon trough is mainly due to the moisture divergence associated with this anticyclonic circulation. And so there are two factors, two regions are very well explained. One is Northeast India and monsoon trough region, and Western Ghats region also received low rainfall because mean southwesterlies are weak in June. And let us move to July now. and this is a snapshot of 24th July SST anomalies. You do see the gradient over the equatorial region is strengthening, so we can expect those maximum anomalies of rainfall can shift towards the equatorial region. And we have seen this, though the southern parts of monsoon trough region received high rainfall, northern parts still has a problem. That is because we can see here this trough, what you can say, this ridge extending from central Pacific to the head Bay of Bengal is responsible in June for the low rainfall. The same one, if you see that in July, slightly moved towards north. And then this is the box where we have a low rainfall in July. So it is the same large scale pattern persisting to July, and you have low rainfall over this particular region. See, these are all evident in this 850 HPA winds. You can see that these easterlies are still the easterlies are still moving towards the foothills of Himalaya there, but south of that we have the monsoon trough has been set very clearly. So the low rainfall over Gangetic Plain, North Gangetic Plain, and all are persisting, and because the ridge is persisting, slightly moved northward. And now, because of this anticyclone over the Northwest Pacific, so there is no chance of very intense TCs. If there are very intense TCs and they are moving towards like Bay of Bengal, you might expect some lows, but it wasn't the case because there was anticyclonic circulation sitting over that. And then how to explain this rainfall pattern in July? One is that ridge, but now why that ridge is not moving northward? So you see that this is a comparison between June and this is July SLP. So July SLP clearly showing high over the foothills of Himalaya, and which is extended from Northwest Pacific. Also high SLP anomalies are seen here. Maybe something to do with this blocking high. And apart from that, there may be a chance that PDO influence. I'm not sure about that, but we can discuss on the masculine high. So if you look at that, there is a huge pressure gradient between these two monsoon trough and masculine high. That is what is driving the strong cross-equatorial flow, and because of that, the ridge is moved from June to July to slightly to the north, and the formation of trough has happened. This formation of trough actually is conductive to the low pressure systems that Senab has explained. So those low pressure systems actually gave a lot of rainfall, contributed to the lot of rainfall in July. So now compare with June. If you look at the pressure gradient, the contours are SLP. So between monsoon trough region and masculine high, the difference is around 20 HPA, and then ridge is sitting right on the monsoon trough and caused weak rainfall. And this rainfall or this monsoon circulation is not very energetic because of these two reasons. And then when you come to July, monsoon trough is formed, but just south of the normal position, and at the same time, pressure difference is huge, around more than 30 HPA, and the strong meridional gradient enhances the cross-equatorial flow and push this ridge towards north. Now setting up the monsoon trough region slightly north of south of its normal position, and also this ridge seems to be not allowing to move the monsoon flow further north. Therefore, there is a stagnation of monsoon flow. And to look at the mid-latitude high here. So when you look at this, this is just I'm comparing with last year's example, and I'm talking about July only for 10 days. That is from 11th to 20th, and see there is a just movement of this South Asian high. South Asian high or Tibetan high very nicely established in July, both in 2021 and 2022. But in 2022, you see that move towards the southeast corner. You see that center is about 110 east, whereas in 2021 it is 80 east. So there is a huge difference, and there is a movement towards southeast. When you have such movement in the South Asian high, and you do see that the rainfall is decreasing, especially foothills of Himalaya. This is the case for northwest movement versus minus southeast movement. So you have to see this in the other way. Say that this should be negative anomaly, circulation should be reversed when it is moving southeastern direction. So these anomalies, vorticity anomalies here, 850 HP vorticity anomalies are negative when there is a southeastward movement of South Asian high. So that is what we are seeing for July case as well. So these are the large scale circulation patterns that explains these rainfall patterns of June and July. So I'll skip this. I'll go to oceanic conditions. So we have a 3-year evaluation of double dip La Nina. So black one shows that the La Nina conditions are prevailing over the Pacific, and it's going to be stronger as per the prediction point of view concern. And then last 2 bars, the blue bars shows that La Nina is persisting. This is a multi-year La Nina. This is based on the Oceanic Nino Index. And when you look again from May to June, so there is no much different in the patterns of La Nina, except there is some strengthening of La Nina signals over the equatorial Pacific. And recent 2 weeks, there's a large difference over the central North Pacific, but elsewhere the changes are weak. And this is somewhat interesting. So when you look at this SST anomalies with time, so in July 2022, you do see Central Pacific has a strong cold anomalies. And when you look at the upper ocean heat content, you do see with time there are upwelling and downwelling Kelvin waves moving towards east from Western Pacific. But this is all happening in the subsurface. But in the surface, these signals are not reflected. The reason for that is there is consistent easterlies. You can see the negative values here. Throughout last 3 years, the Central Pacific shows that easterly anomalies throughout, but you do see in subsurface there are changes from time to time. And this is obviously all region shows cold anomalies, and they are going to be persistent. And this is another very interesting aspect of subsurface temperature anomalies. Centered around 28 May, what you see that the subsurface warm anomalies from the Western Pacific are much stronger, and they are extended to like 150 west. And when you go to with time, they should propagate to the east and upward and kill the La Nina. But it has not happened because you see the development of subsurface cold anomalies in the Central Pacific is happening. So that actually weakened these positive anomalies, and then there is a breakdown. And therefore, again, you see that these anomalies are not enough to kill the La Nina. And again, in the Central Pacific, these subsurface anomalies or positive anomalies are replaced by negative anomalies during July. And this is also reflected in the SST anomalies. That means the equatorial, central equatorial negative anomalies are going to be strengthened next few weeks. And that is also evidenced by a difference of winds from 23rd June to 22nd July. If you see that there are strong easterlies in the low level and upper level, there are westerlies, indicating that there is a strengthening of water circulation. And this is forecast. I'm not going to discuss much because next presentation is going to discuss on this. Obviously, most of the models predicted La Nina case, and here negative IOD is also predicted by many of these models, like ECMW and Meteor, many others. And I'm here interested not only on DMI but basin-wide warming. Basin-wide warming shows kind of positive values suggesting that East Equatorial Indian Ocean warming is stronger than Western cooling in next few months. So this is a prediction for next few seasons based on APCC. You can see that La Nina is persisting and Indian Ocean dipole likely to form, but it may not be very strong. Yeah, thank you.
Thank you, Justin. Very nice talk. Any questions?
Yeah.
Coming to you after.
Justy,
Yes.
can I? Hi, Justy. That's a good presentation.
Thank you.
I liked your analysis. But as far as this, I was quite interested in why the June rainfall was so much below normal and July was so much above normal. And your explanation does link it to several of these large-scale circulation features. But it still remains a bit of a sort of associative, in the sort of causative mechanism. So is it possible to go down into some sort of intraseasonal level so that you can explain why the rainfall has become? So one possibility I can think about, and maybe one should look at, is that although the onset was early, but then what happened? The progression of the June rainfall is essentially due to the first northward propagation of the first pulse of the intraseasonal oscillation. So what happened apparently this year is that was very slow. So there was something was blocking the northward propagation, and that's what essentially limited the resulted into the deficient rainfall in this, and that must be connected in some way with the large scale upper level circulation which anchored it. And so maybe whatever you are saying, if you can link that to the propagation of the northward propagation of the ISO in the month of June, and that might actually link to essentially mechanistically link it to the deficient rainfall. So what is your thought on that? Do you think?
Yes, sir. When you look at the, for example, what I say ridge is also slowly moving from south to north. It may be part of this northward propagating ISO. So I haven't looked at that. Yes, there is definitely a contribution of this ISO moving towards north, because mean ITCZ also moves slightly northward. So these synoptic features may be contributing slightly, moving this ridge and trough formation of trough as well. Yeah, from June to July.
Yeah, ultimately the rainfall comes from these intraseasonal spells, right? So basically, if the intraseasonal spell is suppressed, and that may be due to the northward propagation, and that may be the mechanistically, that may be the linkage between the large scale circulation and the rainfall deficit.
Yeah, northward propagation might be also blocked by this ridge. So we don't.
Right. I think but maybe that is what it is probably. So you should try to link it sort of in a mechanistically how that can.
Yes. Thank you. Yeah.
Okay. Oh, thank
you.
Yeah, usually we get better rain. La Nina, they don't.
Yes.
This is La Nina, but you get a heavy rain during Southeast.
Yeah, actually, when you look at La Nina, it is strong over the dateline and western part on the equatorial region. So there you have to think as a sink, equatorial sink. And in general, La Nina is strong in the eastern Pacific. When you have that sink more onto the east, obviously you don't get extension of that anticyclone what you get in the northern hemisphere. Is mostly restricted to Pacific. Therefore, you have water circulation mean water circulation, and there is no coil, so it can freely generate convection there, and you have a good rainfall over the Indian region. But this case, probably because of shift of maximum negative anomalies. That's not my feeling.
So June La Nina was not exactly as we know that.
Yeah, I have shown composite patterns like rainfall.
If you look at the northeastern region, so there the anticyclone feeds moisture from Bay above. That is why you get more rainfall.
So even El Nino, if you look at the El Nino developing case, you do see high pressure obviously over the Indian region, and you do see anticyclone over the Bay of Bengal. So this is a similar mechanism that is going to have strong impact on northeast area by generating southerlies towards the mean southerlies.
So 30 years to that, actually, I was getting the impression that penetration of this cold anomalies, the equatorial region to the west, is what is responsible for June rainfall. Yeah, but the same extension is there even in July as well.
Yeah, that's true. That's
in that case, what you are trying to argue is that the range has moved north.
yes. And
What is yes, please. So this extension, you are saying that eastern equatorial ocean enhancement of the rainfall is there because of the large oceans in the June. But whereas in July, suppression is there. So same extension is there, but both in June and July, things are very different.
yeah. So the point
how
here
can
is,
we really think that?
I'll try to explain that. In June, if you see the gradient for the equatorial region is slightly weaker between maritime continent and the equatorial Pacific anomalies. And if you look at July, the gradient is slightly looks like stronger.
Yeah, it is because of the other way around. Because the convection is reduced.
Yeah, but if you see the difference I have shown in the water circulation was also strengthening. Once equatorial water circulation is strengthening, those anomalies are more restricted to Western Pacific only, not to the iron. But in July, the mean anomalies are going to be strengthened, obviously, because monsoon is rigorous. So these differences makes the pattern contributes to the pattern difference.
My point is in June, the masculine high was also weak, and July it is intensified. So the gradient also,
It was weak.
could be playing, compensating.
There could be some other.
Correct. It is not. Yeah, it is
This is a
that is also. Another thing is that Northwest Pacific is also likely to be contributing because PDO sediments, native PDO is there.
Yeah, but we are supposed to
question. So that tinted band structure that you showed in June, that we mostly associate with mesos, and in July there was some low pressure system activity that we usually associate with active phase. So do you think there is something more intrinsic to the meso characteristics?
Meso is consisting long time for the equatorial Indian Ocean or maritime continent. Like this kind of patterns occurs. But what is the duration of meso that we have to see one thing? And what is said, the large scale setup has allowed to generate these lows in July. That is going to be a contribution. If large scale setup like June is not favorable, you would not see those lows. Definitely, Angelo must be playing good, but I haven't looked at that.
So one more point: if you look at the Central Pacific SST anomalies in May, the signal anomalies were strong. That was, and it was closer to the western. But now that has weakened in June. So that is why the effect of the anticyclone towards Indian region has slightly weakened. Yes, it was still there in the Northwest Pacific. It has not extended to the Indian region.
Thank you, Justin. Let's
Subodh,
move on next.
Subodh, one question was there from you too.
Me too. Okay,
Yeah.
quickly.
So it was with deficient rainfall in June. So what was the role of large-scale separation induced by MJO in unfavorable phase, like 781? And what about strong East Asian monsoon features in wavefront? So what was the effect in deficiency of June?
Yeah, as
Cell one.
May.
Just mention
No,
it.
name is something. Cell one. Something.
Okay. So
Maybe
obviously, East Asian monsoon, especially central China and Japan, they're going to get good rainfall because you have anomalous anticyclonic circulation. That is going to take a lot of moisture from the South China Sea and going to dump over that northern parts of South China. Therefore, you will have a strong rainfall. Apart from that, there was a cyclonic circulation. So there is a convergence, and Mayo rainfall has got a good rainfall during June. And then MJO role, as I said, if it is persisting like unfavorable condition you were talking about, it may be contributing to the June rainfall, but I have to look into it very carefully, what way it has contributed. Yeah.
Okay, thank you, Justin. Next talk is by Maheshwar Puran. We have time at the end of the this talk. We have some time for discussion.
Subodh, I have a.
Sorry, we have a question.
Yeah, no, I have a request to make. I think we can go ahead with all the presentations and questions can we do at the end? Because I will be leaving in about 45 minutes.
Okay, I will do it.
Yeah, so I think I would like to listen to all the presentations. Maybe questions you can keep at the end if you don't mind.
Okay, no problem. I will do it. Thank you.
Yeah, thank you.
Good afternoon, everyone. So my name is Maheshwar Pradhan, and most of the June and May features are have been explained by Dr. Jasti, Dr. Sana. So I will be discussing mostly on the evolution of monsoon during July. So during last monsoon discussion, the rainfall conditions over India were quite alarming because there is a huge deficit over all India, and there were no major systems that were expected that time in various forecasts. So concerns were also raised for water availability and agricultural yields. And in one of the analysis, Ankur had shown that June deficits, like small deficits, mostly ended up in normal to above normal monsoon. And interestingly, just after the monsoon discussion, so the monsoon has revived quite well, and it was drastically improved over the first 3 weeks of July. And subdivisionally, also the monsoon has improved, except the east and northeast sector of India. So with the deficit monsoon during June, most of the civic bodies like PMC also were concerned, and they started water cut. But within the few weeks, like 2 weeks, the reservoirs were almost operating at more than 60% of their capacity. And the status when compared to last year, it is much improved during the July month. And the media coverage also gradually improved, and luckily we don't have water cut now on. So the agricultural status also this year shows that it is much better than that is compared to 2021, and various crop-wise performance also as of July 15, it is much better than 2021, except the paddy. Maybe I don't have the current data. Maybe paddy might have also improved. And the media media coverage also shows that the performance of crop yields and sowing are better than the last year. To the scientific part, what are the July conditions mostly over Indian Ocean? And if we look at the Indian Ocean, there is in the surface acidity anomalies, this is negative dipole-like conditions that is evolving, and pressure status of IOD index is hovering above around -1, which is quite strong. So most people have this question: is the negative dipole is going to lead a below normal rainfall this year. So to analyze that, I have shown the SST as shadings and Euler and D20 as contours in first two panels, and the wind as vectors in the third panel. So these are weekly anomalies. This is July first week, this is July second week, and this is July third week. So Euler in anomalies in the first week of July was mostly negative. That is conducive for good precipitation over all of the Indian Ocean and Indian landmass. But in the week 2 and week 3, we can see a seesaw pattern of Euler anomalies over the Eastern Indian Ocean and the Indian landmass. So now the Indian Eastern Indian Ocean, the Euler anomalies are positive in the current 2 weeks, and these are quite opposite to what is expected during a negative dipole event. So then coming on to the D20, the subsurface subsurface features like D20, 20-degree isotherm. So this doesn't have any prominent signal over the Eastern Indian Ocean. The magenta line basically shows the zero line, and beyond zero there is no significant signal over the Eastern Indian Ocean. And coming on to the winds, as many of the previous presenters shown that during July, there is a strengthening of southwesterly cross-equatorial flow. That is also seen in this figure. And first week, the cross-equatorial flow is quite strong. And later in the second week and third week, there is a easterly wind anomalies, which is also not seen during a negative dipole event. This is conducive for positive dipole event. So basically, what is happening in Indian Ocean, the surface SST pattern that is quite different than the subsurface and the atmosphere. So there is no proper coupling of surface and subsurface and ocean atmosphere also. And so to answer that, why this negative dipole is not leading towards a below normal. So this is basically an uncoupled dipole mode which is evolving, and this may not lead to a below normal rainfall event. So coming into Pacific condition is Dr. Jasti has mostly covered. Just to go through that. So during July, the Central Pacific has mostly easterly wind anomalies, strong easterly wind anomalies. As a response, the SST also shows negative anomalies, and the Euler over the Central Pacific is also high, which points that suppressed convection lies over the Central Pacific. And the other indicators like upper ocean heat content, thermocline, slope index, they also indicate that La Nina may continue to during August and September months. So coming into the forecast from monsoon mission model from June IC, the July patterns are quite similar to the cumulative anomalies during June and July. The east and northeast sector is a deficit, whereas the southern peninsula has good rainfall. And the August and September months are expected to have good rainfall in spite of a negative dipole event. So this kind of teleconnection, generally it was believed that coupled models have this problem of wrong isomer IOD teleconnection. But in this year, observation itself shows that the teleconnection is slightly is different and similar to the model problems. Coming on to the other forecast from global models like ECMWF Symptom 5, this also shows a negative dipole pattern in SSTs and La Nina pattern over Central Pacific. In spite of that, in spite of negative dipole, the La Nina conditions are favorable for a positive rainfall anomalies over Indian landmass. The Indian Ocean again measures like a negative dipole event. So the IRI, coming to the IRI forecast, the Nino 3.4 index shows that it will be negative and favorable for La Nina conditions. And the probability forecast for La Nina also is more than 50% in the coming season. And rainfall anomalies over India, this model also shows around 50% of probability of good rainfall over India. Europe meteorology forecast, so the IOD, this also again shows strong negative IOD event in the month of August, and also that prevails up to September, October month. NMEM multi-model forecast also shows strong negative dipole-like pattern in SST and a strong La Nina pattern over the Pacific, which gives rise to a good rainfall rainfall over Indian landmass. So just to summarize, over the Pacific, the SST patterns reflects La Nina-like condition. Over Indian Ocean, the SST pattern reflects like negative IOD condition. In spite of the negative IOD condition, it is not leading towards a below normal rainfall because the IOD is basically uncoupled. And that's why good rainfall is being predicted from various models during August and September. So that will be all from my side. Thank you.
Thank you, Marcel. We'll take the question at the end. Now, next speaker will be Raju Mandal.
Should I start now? Good afternoon, everyone. So, myself, Raju Mandal, will be talking about mainly the performance of extended range prediction system from IITM and different institute. And basically predicting the advancement of monsoon 2022. Whatever will be shown in this presentation is from the contribution from all the members of IITM ERPS group member. So this is the outline of my talk. I will pick up where we left off in the last monsoon discussions. Then we'll show how the monsoon has been during the last 4 weeks. And then main part is the forecast verifications. And finally, we will see how the monsoon is going to be in the next 2 to 3 weeks. This is the summary we have shown in the last monsoon discussions. It was presented by Abhijit Dey. So that it was based on the 29th June initial conditions. So from this weekly average rainfall anomaly, we can see that the forecast was like this, that rainfall was likely to be normal to above normal for the next 2 to 3 weeks over most part of the country, except this Northeast Indian region. In the all 4 weeks list, it is showing the subdued rainfall activities. From the idea average percentage rainfall anomaly also showing the same pattern. Over the Northeast Indian region, the whole month basically showing the negative anomalies, largely negative rainfall anomalies. And the MISO also showing the strong MISO also was showing, indicating the same pattern that monsoon is going to be active in the month of July. This is the observed daily rainfall series over different homogeneous regions. This is the Northwest India, which was near normal. And if you see the East and Northeast India, it is the whole month is subdued. And over the Central and Southern Peninsula, first 2 weeks was very active. Then it becomes quite normal. And this is the monsoon zone region. So there was an extended break during the month of June. Then the monsoon revival happened in the beginning of July. And after a very strong activity, it became now near normal. And the observed MISO, the purple line shows the MISO during June, and the red line is July. So you can see from the beginning of July, the MISO, large-scale MISO signals was very strong. And at the 8th of July, it went to the foothills. And this is the now current situation. This is updated up to 27th July. The verification for the week 1st to 7th July, and this plot is from the current existing extended prediction system operationally run by IMD. So we can see this is the observation, and the subsequent balance are showing for the 3-week leads. This is week 1, week 2, week 3 leads. So we could say this during this target week, the monsoon activities were quite heterogeneous. Over this part of monsoon activity was very good, normal to above normal, but over these regions it was very less. And from this IMD ERP version 1 also we can see this almost it could predict these features up to week 2 leads, though the magnitude was different over different regions. But this is the Multiphysics, our new operational version 2 extended prediction system. So we can see from this up to 2 weeks leads, the pattern was reasonably well predicted and better than this one, version 1. And this is from the NCMR forecast system. This is observation and 3 weeks leads. So here also we can see, but there is a problem that the convection is swinging towards the northern side, shifted toward northern side. This is the next week, 8 to 14 July. So here also we can see the monsoon is very strong over these central parts and northwestern region and parts of southern peninsula. So here also we can see the IITM multiphysics ensemble prediction system predicted very well compared to others. And this is the meso predictions along with the verification. Blue lines is the observation and green is the MME. So from this 6th July IC also we could see that monsoon activity is going to be very strong, and at the end it is going to be in the foothills regions. So and this time period also there was a lot of synoptic activities, which was mainly I think embedded with this large scale signals. So that was monsoon activity might be very strong. And this is the next week, 15 to 21st July. So in this week also monsoon remains active over these regions, but again these regions, northeast and parts of this central India remain subdued. And that was also well predicted by this new version 2 ERP systems compared to others. And meso signals also showing the same. The last week of this is a recent week, ending by 27th July. So where also we can see the monsoon mainly active over these foothills regions, though there are some parts of Santa Peninsula regions also active, but the Western Ghats is very strongly negative anomaly is seen, and that is also very much well predicted from all the leads, 3-week leads. And this is matching with this meso forecast. And this is the verification for percentage anomaly rainfall area average over the monsoon June and all over India. So we can see this is a week 1 lead for this is week 2 lead and week 3, week 4 leads. So we can see in up to week lead the prediction was very good. Even week 3 initially there is some phase error. After that the prediction is going very well. Once the monsoon set up very nicely. So this is the statistics till now. So from June we can see, except this east and northeast India, other parts were very largely negative, the rainfall. And in July, except northeast, other parts became very positive, and the northeast India became very negative. Though there was a very, we can see the positive departure here over the east and northeast, but the rainfall mainly was confined over the hilly regions. But over the plains, till now there is no sign of good monsoon. And we can see in July also till it is deficient. So it's very much important for the agriculture point of view, how the monsoon is going to be for the next 2 to 3 weeks. And that can be seen from this latest forecast based on 27th July initial condition based on the multiphysics multi-ensemble prediction system. This is the actual rainfall weekly average for the next 4 weeks, and this is the anomalies. So as already previous speakers talked about these things, that most part of the central region going to witness the dry conditions of the kind of conditions in the first week. Then the monsoon activity will be very normal to above normal within week 2 and 3, and then again in week 4 it is likely to move towards the foothills. And this is the area average percentage anomaly. So in the central India also we can see the first week the probability is very high for this deficit rainfall. And northeast again it is showing for the other weeks. Though then in the first week there is a probability that there will be some rain, but after that the rainfall probability is very less. And other regions also showing the good rainfall activity. And that is also seen from this mesophase diagram. The clockwise rotation shows that the monsoon interseasonal oscillation, the convection belt is moving from this southern tip to the central India, and at the end it is going to the foothills. And the signal is very strong, and the propagation was very fast. That is also can be seen in the mesofiltered rainfall spatial pattern. So week 1 there is a break phase, and after that very strong anomalies is seen over these regions, and movement is also very fast. And then at the end it's likely to move from towards the foothills. This is the subdivision wise categorical probabilistic forecast for the 4 weeklies. So in weekly also we can see the same results. Most of the subdivisions are going to get this subdued rainfall, and after that very strong rainfall. Though this part, this West Bengal, Jharkhand, and this Assam, and these parts are still will remain in the less category. And after that, the rainfall activity is going to the northeast and foothills regions. These are the conclusions. We have seen that compared to the other models, the multiphysics reasonably well means predicted comparatively better during the advancement of the monsoon during last month. And the next 4 weeks forecast will be the normal to above normal rainfall over the Indo-Gangetic plains, part of South India, and most part of Central India is likely to experience dry condition in the week 1. And week 2, 3, normal to above normal rainfall over most parts of the country, except parts of Northeast India. And week 4, monsoon activity likely to move towards the foothills from Central India, as seen from the large-scale signals also. These are the forecasts from different centers. This is our next version of ERP, and this is NSEP. Those are dates are little different. We have plotted from 21st day onwards only, and this is latest available forecast from 26th July. And these two are same, that is 29 July onwards. This is NCMRWF and ERP version 1. So most of the models are showing the similar pattern. First week dry conditions over this, and after that good monsoon, and again it may go to the foothills regions. So that's it. Thank you.
Thank you, Raju. Next talk would be with Tanmay Goswami.
Good afternoon, everyone. So I'm going to discuss the observed features and model prediction of a few heavy rainfall events week by week. So this is the weeks starting with the 30th June to 6th July. So on this week, there's not much any low pressure system or any but from I think 3rd of July there is a cyclonic circulation, and with that there is some rainfall activity. This cyclonic circulation traveled northwestward to Gujarat, and on 6th there is a heavy rainfall on this region, and this is the weekly rainfall departure. So during this week, east and northeast India and received 36% deficit, and rest of the region, northwest India, central India, and southern peninsula, all are abnormal. Now, I'm taking the 6th June heavy rainfall case. So this is from GEFS forecast, day 1, day 3, and day 5, and focusing on this region. So it model is able to predict this rainfall with all the lead times, and the probability is also, this is the rainfall greater than 15.6 mm per day, and this one is the rainfall greater than 65.5 mm per day. So it is showing more than 75% probability over this region for day 1 and day 1 forecast, and with lead time the probability is reducing, and also over this card section also the heavy rainfall probability is there. And this is the percentile based forecast from GFS and its probability from GEFS. So this light and magenta color is rainfall more than 90th percentile, and the dark one is 95th percentile. So categorized as heavy and extreme rain. So you can see model has indicated extreme rainfall over Gujarat region, and also this Kerala over Kerala, and it has the probabilities also strong more than 50 to 75% probability of rainfall over these regions. Now in week 2 there is a development of a low pressure system, so it is moving gradually northwestward, and on 13th July it is strong, and this is the associated cyclonic circulation. So it is also moving northwestward, and this is the associated rainfall. So on 13th, the maximum rainfall happened here. Yeah, this one. So this is the again weekly accumulated rainfall. So here, except east and northeast India and northwest India, all other parts receive excess rainfall. And this is the again 13 July heavy rainfall case and this region. So model has able to capture this in day 1 forecast, but in day 3 in this region it is overestimating this one, and the probability is also in similar line. Now for percentile also it is day 1 it is showing the extreme rainfall and with high probabilities. So this is the 3rd week, 14th to 20th July. So the local system of last week has weakened and it traveled northwestward here. So it is the cyclonic circulation associated with this is also here, and due to this it has received many parts of India received widespread rainfall, and on 18th this region central India region, Madhya Pradesh and parts of Maharashtra received heavy rainfall. So again, except east and northeast and northwest India, all other part received excess rainfall during this week also. Now, if we go to model forecast, so GFS is able to predict this with all 3 time, 1 day, 3 day, and 5 day, and it is showing probabilities also high probability of this one greater than 15.6 mm per day. And from also it is giving indication of extreme rainfall with day 1, but for day 3 and 5 it is slightly shifted to the east. The probability is also same. Now this is the week 4, it's 21 to 26. Now in this week there is not much any low pressure activity, and so rainfall is also, I mean, not significant, except some a portion of India, central India received rainfall. But here there is one cyclonic circulation which moved northwestward, and here up to over Gujarat and Rajasthan on 24th. So because of that, this part has received rainfall, heavy rainfall. And the model has able to predict this with day 1, day 3, and day 5 lead. And it also gave the probabilities of rainfall more than 15.6 per day. A percentile also, it has given the indication of more than 95th percentile rainfall over Gujarat, and with significantly high probability. Now the forecast based on 27th IC. Again, from MSLP charts, there is not much activity. Hence, the rainfall is also mostly moderate on our Indian region. So here only this one probability greater than 2.5 is showing high probabilities. And for this category, some part of North India showing more than 50% probability. And for the percentile forecast also, this is the day 1, day 3, and day 5. So this is for valid for 28th, 30th, and 1st August. So this is also on mostly showing a heavy rainfall in some scattered places, and extreme only for 30th August in few locations. And for 1st August, it is showing extreme rainfall over Tamil Nadu and coastal Odisha. And these are the associated probabilities. And this is the new initiative from our group. This GFS and TCO grid. Open this link. So this is running in experimental mode right now. Thank you.
Thank you, Raman. Okay, next talk will be by Professor Goswami. Are you, sir? Sir, are you there? His mic is off. Mic is off. Mic is off. Mic is off.
Just check. The chat box is right.
Yes. Yes.
Okay. Sir, next talk will be by you. So he will talk about mainly on why this year Northeast was very wet and rest of the India.
Okay. Okay. Just let me share my screen. Oh. Is it visible? The screen?
Yes, sir. Yes. Yes.
Okay. 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 1 minute. Okay. So I just want to share a few things that that we have been looking at in the Northeast rainfall, and we are generally following what is going on in the Northeast. Hello.
It is not full screen.
Oh, it is not full screen, right. So I'll make it full screen. Okay. Okay. So basically, we are looking at this year. I have been concerned about a couple of issues regarding Northeast climate. Having been located here for the last few years, I have been seriously looking at the Northeast climate, and it turns out that there are several things that we don't know about it, and a couple of problems actually bothered me for some time. And the two issues that actually was of interest is that we have always said a May rainfall in the Northeast is pre-monsoon rainfall, and according to IMD's definition, the onset takes place in the first week of June, and therefore the rainfall is always considered. But in my experience and my I am quite convinced that the May rainfall is not pre-monsoon rainfall, is actually the monsoon rainfall, and that's partly because you can see that and then I'll demonstrate in a minute that the May rainfall is actually is much larger than the rainfall of June in central India, and therefore how can you say that? I mean, still rainy season has started. The point is that is it monsoon rainfall or it is pre-monsoon? But how can you call it pre-monsoon? Because normally these rainfalls are not isolated thunderstorms, and these are very large-scale rainfall, all these things. And so why do you call it pre-monsoon? That has been one question that I have been, and still the answer is out, it's not yet out, but we have some ideas. And the second question is that what makes this? Basically during the month of May and even April, there is a considerable amount of rain in Northeast, and they are all organized, but ITCZ is nowhere around. What produces the large scale? And there is nothing like low pressures or depressions during that time. But somehow some large scale systems are actually forcing orographic rain. Now, what are these large scale systems that produce? What are these large scale systems? And that is something we did not know, and something that has been bothering me, and trying to figure out what that could be. And for that reason, we have been actually following this year's monsoon quite closely, going on a sort of day-to-day basis, and looking at what kind of circulation and the convection patterns that affect the Northeast monsoon rainfall in the month of April and May, and also in June. So it was a pretty early part of the monsoon season. Now, one thing that actually was during this period, one thing that was quite striking, that every day to day, if you look at rainfall, the cloud patterns, you see this kind of a pattern was very persistent. Like there is cloudiness above the Tibetan Plateau, extending up to China, and with a significant amount of cloudiness over the Northeast region. But of course, very, very clear sky, which is not normally in this time of the year. This is very normal, but this is very striking actually. So this is the demarcation is around the Himalayas, and this is essentially, it indicates that there is certain large-scale extratropical circulation, which it produces these stationary kind of waves, which cannot and does not produce due to subsidence, and other regions does not produce any convection in this region, but it allows to produce convection starting from Northeast India. And in fact, the convection is quite deep in that. This is a particular day in April, and you can say it is very similar pattern persists in many other days in May, and similar kind of organized. This is quite organized actually. It's not just isolated. This is over the whole region. There is the deep convection, and same thing is another day of May. So these are quite, we felt that there is a certain, on the top of this extratropical Rossby wave that keeps on traveling, on the top of that, there is actually a stationary wave that is anchoring these. And that could be seen actually by, even if you do the monthly mean cloud cover map. So we look at monthly mean April and May, and you can clearly see this kind of a stationary pattern. So even on a monthly mean sense, there is a pattern that actually is anchored there. and that pattern, there is more cloudiness from eastern India extending to South China, and then of course this is a no cloudy pattern. So this pattern is associated with some large scale circulation, and before going to that, let me just tell you that the rainfall in this during the April and May are quite large scale. For example, this April, this is the time series of rainfall anomalies averaged over that region. So I'm going to consider this region as the sort of northeast region. So basically, this little box here over there, and then average the rainfall over there, and you see that there are these spells, and the spells even in April there is a long spell of rainfall, positive rainfall, and then May there is a big spell, and of course in June there is a very heavy spell. So these are like some sort of intraseasonal activity taking place even starting from April, but these are not tropical intraseasonal modes. These are something that extratropical systems are modulating these. And this rainfall, even in April, it is quite organized. Of course, you can see that these rainfall are essentially orographic. So there is an orography. I will show you in a figure a little later. There is a horseshoe-shaped orography in this region, and so this rainfall is along the lee side of the orography. There are some winds from this South China Sea, and those winds that produce orographic rain in this. But they are organized. So the winds are of large scale nature, and this average over even a week or 10 days. This is a very large scale rainfall. So in other words, these rainfalls are not due to isolated thunderstorms, and they are organized, but they are organized around the orography. So orography anchors the rainfall and then organizes it. But it requires a large scale conducive wind for the uplift. So that is how these rain. So this is just to establish that these episodes are large scale. Now, coming back to the question of these rainfall, whether it is monsoon rainfall or not, we believe that they are in the May rainfall is definitely monsoon rainfall, and that comes from the fact that the onset, if properly defined in this region, is actually took place this year around 9th of May. And this onset is defined as the tropospheric temperature gradient between this box and this box, which essentially means the heat source here is becomes stronger than the heat source on the south, and therefore it produces the northward flux of it changes the vertically integrated northward moisture flux around this outer box here around that time. It is just like in the Arabian Sea when the monsoon jet, low-level jet, accelerates at the onset time from almost no values to about 10 times larger values and stays like that. And that is exactly what happens during the at this point of time. That means monsoon heat source has set up and maintained, and that heat source is driving moisture flux from the south and keeping it on. So therefore, I think we need to reconsider this in our definition of the northeast monsoon, and this is something that I have been arguing. So going backwards now in the so what was the rainfall during the April, May, and June during this year? It turns out that if you go back to the record of TRIM in over the last 21 or 22 years or whatever that data we have, and it turns out that if you do sort of calculate the anomalies of monthly mean anomalies of April, May, and June, it turns out that April was significantly above normal, as I showed, because of that spell. There was a big spell, and this was about almost two standard deviation above normal. The May was also about 1 standard deviation above normal, and June was almost twice, two standard deviation above normal, more than 2 standard deviation above normal. So in other words, this was very peculiar in terms of the May and in the Northeast, because all 3 months, April, May, and June, were much above normal. This has consequence in terms of hydrological implications, because I think people don't think about it, but the hydrological implications are very serious. That is why this June we had such a tremendous devastating flood, because the dams were already filled up by April and May rain, and the Brahmaputra level was also raised, and therefore when there was a very wet spell in June, the flood intensity was very, very severe, and it affected a lot of people. So I think we need to, our warning of flood needs to look into these things of history of rainfall in the region. And if there is abnormal rainfall in April and May, and if there is a spell expected in June, I think we should seriously warn the flood warning. A strong flood warning should be given, and be prepared for that. So these are, I think, the issues that also needs to be discussed. So what caused this excess rainfall in this region? So let me focus on the May rain. Although June rain was even stronger, but the May is important. So it is similar. The June also, the anomalies are somewhat similar. So if you look at the 200 millibar the geopotential and circulation anomalies during May, it turns out that there is this large scale anticyclone. On the top of that anticyclone, there is this cyclonic anomaly sitting to the east, and this kind of a pattern is essentially responsible for producing the excess rain in the northeast region. And let me show you how that happens. So what causes that? Basically, to understand that this anomaly, this is a very simple calculation. You just remove the zonal mean and do the climatology of the anomalies of all these years, and this is based on ERA data, I think. Yeah, about 90s. So if you look at that climatological May anomaly, actually climatological May anomaly has this anticyclone sitting over here, and this is a very classical about wave number 2 pattern, which probably something like Srinivasan and Joseph had done a long time ago. And that kind of a pattern is there. It is always there. But on year-to-year basis, so this is caused by some multi-decadal variations or things like that, right? Like the AMO and things like that. But on the top of that, there are internal variations which are caused maybe by El Nino and other things. And those patterns cause of these, or strengthening or weakening of this in different periods. So, for example, if you take the years which had the excess rainfall in the northeast, May excess rainfall in the northeast, and take the difference from this climatology, then you find that excess rainfall time there is a cyclonic vorticity sitting on this on the eastern side of this, and the eastern side this anticyclone becomes weaker, and western side the anticyclone becomes stronger, and so the subsidence on this side become. These happen to be, these are all barotropic vortexes, so they sort of produce subsidence downwards associated with them, and or weakens the subsidence, and therefore promotes the updraft in this region. So this is what seemed to have happened this year, and how is it? What drives that? So if you look at the May rainfall and over the last 44 years, and sort of May rainfall over northeast and and your regression with SST, it turns out that is very strongly correlated with the El Nino, and therefore ENSO seems to be a major driver of the May rainfall in this region. And that, so if you then look at what kind of circulation anomalies are there associated with ENSO, and it turns out that that is what exactly what is the circulation anomalies that essentially give rise to this kind of a, here it is because you are regressing with El Nino, so La Nina is associated with positive, but ENSO is positive associated, El Nino is positive associated with the anticyclone to the west, and cyclone to the west and anticyclone to the east, but La Nina will be associated with an anticyclone to the east, west, and cyclone to the east, and that is exactly what has happened. And this is barotropic. If you go to 500 millibar also, you can see the same pattern, slightly weaker in amplitude, but the same pattern. So it essentially a sort of extratropical stationary wave, which is forced by the tropical heating, or subtropical stationary wave, which is forced by the subtropical heating associated with El Nino, which has this structure, and that is essentially is also can be seen from here, that if your tropospheric temperature anomaly, if you regress that May rainfall or El Nino, essentially El Nino ENSO gives a negative tropospheric temperature anomaly associated with El Nino, and positive temperature anomaly to the east. So the east-west part of the tropospheric temperature is modified by El Nino in this way for making it conducive for the rainfall in the northeast to become also strong. So this year, of course, we have a La Nina. Instead of negative anomaly, we expect positive anomaly, and that has affected the northeast rainfall also. So how does this rainfall actually is organized? I believe that this is so basically the conclusion is that this year I think the May rainfall is largely contributed by La Nina through a sort of tropospheric sort of subtropical stationary wave, which is modulated. The climatological stationary wave is modulated by the interannual stationary wave that is generated by the La Nina, and that produced a conducive circulation anomaly, a cyclonic circulation anomaly to the east, which essentially gave rise to anchoring the large-scale circulation in that region, and which then interacted with the topography, giving rise to the enhanced rainfall. The rainfall here is essentially topographically driven. In April, obviously, rainfall, there is no ITCZ or monsoon has not started really, and therefore these extratropical the stationary waves produces a barotropic structure which have a certain low-level wind component. Those wind components actually interact with the mountain and give rise to these rains. From May onwards, as you have seen, the onset takes place, the Bay of Bengal rainfall contributes, then winds move like this. These winds then interact. So this is the mountain. This is a interesting structure of the mountains are very important. Here it is like a horseshoe-shaped mountain. It's unlike the Western Ghat where the mountains are north-south oriented, very narrow, and therefore the rainfall is to the west. So it is in a kind of line rainfall. Here what happens is the winds penetrate and also interact with the northern part of the mountain, giving lee side mountain rainfall on this side. The winds are also interacting from the south here on the southern belt of the mountain, also gives rainfall on the south side, like over Cherrapunji, Shillong, and on the north side as well. But the distance between in between the space is so limited that the whole thing becomes a large scale heat source, and therefore it further attracts the winds towards it. So it is the interaction of the winds and the mesoscale orography in this region results in this relatively strong large scale heat source in this region and maintains it. So it doesn't need edit or low pressure systems and all that. So it is mostly driven by the large scale winds. So I think that is the point that I wanted to make, and I didn't want to take too long. But the point is, the 2 points I want to make is that that we need to revise our monsoon onset in the northeast, and we need to give some more importance to the northeast rainfall, in the sense that the prediction of the northeast rainfall, in the sense that the northeast is definitely very important, and that is how we can define a northeast heat source, because on internal time scale, as is very clear in this year's rainfall, the northeast and the rest of India are going out of phase. The June rainfall was too large in the northeast and too low in the rest of the India, and the July rainfall is too large in the northeast, rest of India, and too low in the northeast. So this is going on out of phase. So actually, northeast and the rest of India are two nodes of internal variability, dominant pattern of internal variability. We know that. So I think we need to look at them as two different important nodes, and the prediction also are important for them, at least the two different two entities of the monsoon system, and to improve that. And we have learned that it may be much more difficult to, because of the topographic interaction, much more internal variability in this region is much larger. Therefore, it may be more difficult to predict. But we need to sort of focus a little more on trying to improve the prediction of this system. So with that, I'll stop and thank you.
Yeah. Thanks a lot, Professor BNG. It was very nice, very stimulating. I really enjoyed your presentation, and also all the presentations.
Thank you.
Particularly, you have raised a very important idea that it is not thunderstorm, it is not related to ITCZ, it is large scale, and its interannual variations that we saw this year is related to a stationary pattern from the mid latitude, and it has important hydrological consequences. It was very nice.
Thank you.
And it is linked to also the La Nina ENSO conditions that can.
Correct.
And there's a lot of internal variability within the region, orography, and so on. Yeah, just one question. Not a question. Is it somewhat like the Mayu Bayou front, the mean rainfall that you see in this region? Is it somewhat similar to the? Because that's also a subtropical front.
I don't think so, because of the orography, there is still a barrier between the extratropical low-level winds and the tropical. So if in fact in the East Asian monsoon, there is no such barrier. As a result, the low-level low moist static energy air can come and mix to the high moist static energy air, and that causes a different convective activity. But here it is basically dominated by orography. Now it can the large scale produces, it does not bring in moist static energy. Moist static energy does not get mixed up, because the orography, the Himalayas does not let the low level winds to come in, and the moist static energy does not get mixed up with these. But there is if there is a barotropic circulation, a barotropic pattern, the circulation is modulated even at a low level. But that modulation at the low level brings in moist air from the South China Sea. Okay. And that moist air from South China Sea brings in and initiates the convection.
Very nice. Yeah. Thanks a lot, BNG, and Subodh. Also, thank you. I'm really rushing to the airport.
Okay.
And,
okay. Thank you.
Sorry. I really enjoyed the presentation. Hope you will continue with the discussion. Yeah.
Okay. Have a nice journey.
Okay. Thank you. Thanks a lot. Yeah.
Yes. let's move to the question session. Let's start. Yeah. Sir, do you have any question? You can ask.
I don't have a question, but I have a couple of comments, general comments. Can I make make them at this point of time, and then maybe we can expand this comment. So I think one thing that I have enjoyed all the presentations. I think the quality of presentations have significantly improved over the years, and then as far as the extended range prediction is concerned, I had a couple of questions. Can I raise them at this extended range prediction? I think Mandal.
You can answer. Yeah, you can ask.
So one of the questions that I had is that I understand that your multiphysics model seems to make a better prediction. But what it is actually, just for my own this thing, what is the multiphysics model? Can you? Maybe I have lost that. I have not been in touch. So can you explain what is the multiphysics model?
Yeah, Raju will answer.
Yes, sir. In the last presentation we have shown, but you were not there, so I'll show.
You can explain.
Yeah, you can explain quickly. No, you just by words you can say what is it.
You can explain what is that.
What is the multiphysics? Yes. This is a combination of a different physics scheme.
Like example.
Jhao.
The combination of different physics, right?
Yes.
Give a country.
So this is the multiphysics scheme actually, but the whole these things flow chart. So we have different convection and microphysics schemes. Three convection, that is SAS and this NSAS. And along with that we have the Jhao and Carr and Ferrier microphysics. So with this, and also the NSAS with shallow convections. So these three convection scheme and two microphysics, altogether 6 combination we have. And also this prediction system is seamless. That is, first 15 days running with high resolution T574. And after that, the rest of the 20 days or whatever it is running with T382. That is a seamless prediction system. So with this 6 microphysics options we are running, and with now we have started with 3 ensembles also, 1 control and 2 perturbations. So total we have 18 members, and only based on the CFS. So that is called the multiphysics multi-ensemble.
Achha, so what on what basis these combinations were selected?
Actually, in CFS, I think this default is now in that SAS one, but we have seen many occasions with the different physics that sometimes some physics is predicting some systems, especially for extreme. It was designed for a PhD thesis, and some especially for the extreme weather events. So we have seen different in different occasions, different physics is giving the good predictions. So while taking these combinations, we have shown the skills also. It is showing the better skill rather than the different model, different resolutions.
So is multiphysics means like a combination of physics is one model, another combination is another model. Like that, you have multi-model or what? You are making multi-model predictions, and then or what? Is it done like that? Or?
With this one combination, that will be the one model, and with another combination, it is another model. Like depending on the schemes only, 6 combinations.
6 combinations. So there are 6 models. So so you use all these 6 models to make predictions.
Six models. That means with 6 combinations, and each model is having 1 control and 2 perturbations, 3 ensembles.
1 control and 3.
6 into 3 ensembles.
Okay, I got it. Okay, so but you did not show probability. Why don't you show probability? Because I was wondering that.
Subdivision was also.
Did you show?
This is the one subdivision wise categorical probability forecast that is based on the 18 members week wise.
Okay.
So here we can also see this subdivision wise, what is the probability.
Categories,
normal and normal.
Okay. All right. So sort of the
this is the
this is also here also probabilities are there. Where are the probabilities?
This is a skill, sir. ACC.
Oh, this is skill.
This is the existing one, and this is the new version of this multiphysics. So we can see up to week 2 list, there is a lot of improvement in terms of correlations. Even week 3, most of the subdivisions are having the better skill.
That is what I wanted to see. Yeah, skill. Okay. Good. Okay. Thank you.
Thanks.
Thank you.
Any other question?
No, I have. Shall I make my comments, general comments, and then maybe we can move on to the Subodh?
Yes. You may.
Okay. So as I was saying that the presentations are very nice, but I think we need to, one point I believe is that that in the presentation we should always focus on the peculiarities, and if we can give some idea about the potential drivers of these differences. Just like this year, obviously June was very poor and July was very strong, and what is the difference? And I see that there are presentations which actually tried to explain that. And so like that, even in the extreme event presentation, for example, the short trends presentation, I think we should try to understand why there are certain extreme events in this, and what controlled those extreme events. So in that context, one thing that I am seeing missing is a discussion on potentially. Now it has become very important that every time there is a big event, people will ask, is it related to climate change? Because definitely the probability of having these extreme events have increased as a result of climate change, but we don't have a quantification. So for example, this year's flood in let us say Northeast, devastating flood in Northeast, flood in July in Karnataka, flood events in Gujarat, for example. These events are very important, but the public will ask why are they related to? Generally, we say that probably they are related, but I think there is now a lot of work that says that attribution of these extreme events to climate change, and attribution work can be done, and I think the IITM should take up some of this work, because IITM has the resources, the computers, and everything. I think, and the attribution of these extreme events to the climate change, whether or not it is related to climate change, how much probability of these having, how much has it increased due to the climate change, and these things, if we can quantify, that will be very important. And so in this monsoon discussion meeting, maybe one presentation we should have in the coming days and days, a section of this kind of a discussion. What is the role of extreme events, role of climate change on this extreme events of this particular year? So this is one suggestion, and maybe Krishnan has already left, so this was generally I am making a general suggestion. Maybe you can think about it. So that is one issue that I wanted to mention. The other part, of course, I mentioned already about Northeast. So with that, my comments are limited to that at this point of time. I'd like to hear others, the comments, and then maybe during that, if there is any point of discussion, I will join.
Okay, thank you, sir, for your comments. It is anyway recorded, so we will pass it to CCCR group.
There were a few questions from.
We can ask.
So some CCCR people can. Yeah, we'll start the discussion. So may I start from Dr. Kumar?
Yeah.
whole discussion, or you want to ask any question? Yeah, he will be able to.
Yeah, I have no specific question as such. I really enjoyed all the talks and congratulate all the speakers for the excellent aspect that they have brought out. One point I would like to make is that we need, apart from verification of observed and predicted rainfall and other aspects, I think we should also look at the diagnostics, where we have gone wrong, why the models actually failed to capture that aspect, and also where we have actually got it right, what actually led to that success. I think there should be a focused discussion on the model attributes, the modeling aspects, which can help us to actually work on those things much better. I think that particular aspect is, I think, not very strong in the collection of presentations we have. I hope we can actually look at it in the next sessions. Thank you.
Okay, it's very great, sorry, sir. And I think next presentation will try to, whoever is presenting will bring some analysis why it failed, because we have already. Okay, so Patura.
I should have taught as a seniors, but it's giving the response. Yeah, the response to PNG and whatever. So PNG, good to see you after a long time.
Yeah.
PNG Parthu here.
Oh, hello. Hi, Parthu.
Yeah.
Oh,
I still can't see you.
you cannot see, right? Please come here. Here somewhere.
See, the basic purpose of having the physical meeting is eye-to-eye contact, right? We are tired of looking into laptop. Are you able to hear now?
Yeah, I can hear you. I can hear you and partially see you also. Yes. I can see you now.
Okay. So very nice to see you all. I mean, you should be present in all the monsoon discussion. Like monsoon onset, you have created a onset in our mind today by saying this northeast. So and what is suggested for short range, we are still grooming people who joined us. I'm not very happy with what Tanmay presented. Okay, I'm very happy with the way Justy presented. So this flavor what Justy presented, that can be an example. Okay, so models are producing. We are not messing just to say it is happening this way, it is happening that way. We are imagining. We should add our own. That's what BNG and Kumar is telling. Having said that, BNG, I have some few points from your presentation where you showed that the large scale in the northeast, that figure. So my question is it that in that rainfall distribution, the rainfall that has been contributed by thunderstorm, that has been removed or that is included?
No, it has not been removed. It is not removed. The thunderstorms, no, it is not removed. Nothing is removed. So it is basically average. So average 7 days. So there must be some few thunderstorms in between.
Some artifact coming from.
Right. Correct. No. There are thunderstorms, but it is not only thunderstorms, isolated thunderstorms. So if the thunderstorms have a scale of about 30-40 kilometers, and if there are even if there are 10 thunderstorms which are distributed all over the place, it will not give you that rain. That 7-day average rain, I am getting like 30 millimeter per day. That's average over 7 days. That rain you will not get by thunderstorms. Right.
Yeah,
so
his thunderstorm cannot produce over that whole region a two standard deviation rainfall anomaly.
Correct. Exactly.
Yeah, so that's very good. That's require a lot of our research in using diagnostic, etc. Now I will ask you one question. Assam State Department, Assam State Disaster Management Authority, ASDMA, they are now taking our data, So what they are taking, after particularly this June episode, every day we are now sharing our data to Assam State Disaster Management Authority. Is
very good.
So they are
taking.
It's good. But I'll come to a very specific question. I want to hear from you as well as Kumar, everyone, whoever is present in this room. The point is, see, a model has its own limitations. So we are running a 12 kilometer. Tomorrow we may run a 6 kilometer, but still it is a 12 by 12 kilometer grid, right? It's a 12 by 12 kilometer grid. Model is producing a grid average rainfall, right? So the standard deviation that you showed 2SD, okay, from the tree comparing the anomaly based on 22 years, I am sure if you go to station level, I am damn sure that that is standard deviation will stand at 5, 6, 7, or even 10 standard deviation. I can guarantee.
Absolutely. Absolutely.
Yeah. Yes. Now the point is, now here is the crux, BNG. The point is a model, no model on earth can capture anything, beyond 3 standard deviation. It is not the cup of tea of the any numerical model. So now here is the catch. Now the disaster management people or the dam people, they are expecting that level, that scale, from the model. Okay, where model will go. You can see our weather forecasting paper on the Kerala event. We have compared all the models, ECMWF and Unified Model and GFS and all these. So moment we consider the probabilistic skill with a rainfall threshold more than 3 standard deviation, model doesn't show any skill, with the lead time. So the point is, how do we bridge this gap? This is my question.
I'll tell you. I think we should not confuse, and you should not. They should not also get confused. I think the Disaster Management Authority does not need 6 kilometer forecast accurately. What they need is the larger scale. That is what puts the input on into the reverse. The larger scale, the model is doing very well, and you should actually tell them that. And the models are also predicting the extended prediction pretty well. And this is all they need. And this is what they should use properly. What you need to tell them is don't worry about this. This has to be probabilistic. And I cannot tell you exactly what will happen in Guwahati or in Tezpur exactly. But I can tell you what will happen in all the northeast, the catchment area. That I can tell you with much more confidence. And that is all they need. And all they have to use is them appropriately. They are not probably using even the integrated effect of April and May. They are not using, and they suddenly simply one day rainfall is not going to produce the flood. Flood is produced by the accumulated rainfall, and that requires the history. And the history is also today models are giving better. So you have to communicate it properly and educate them, and you have to educate them. But but what my point was, I was not blaming you that you can give you better forecast. I mean the 2 standard deviation. I mean this kind of extreme events that accurately. But what I'm saying is that these extreme events, the ensemble of these extreme events, if there are many more of those in a particular area in a particular year, what may be the large scale drivers of those? Those things we can at least attribute. Some attribution can be done. That should be a part of our investigation. Attribution of why certain year we have these certain places we have more extreme events and some years less extreme events and things like that. So these are this is what it will give us a better understanding and better confidence in the prediction.
That's what we are doing, and they're taking these products and they're trying to use it with GIS and use it for the society. Yeah, that's what we are. But many thanks for suggestion. Last point, what Rukumar suggested about the see this verification because it's basically the time. This monsoon discussion is announced. We are in the middle of the season. What we normally do at the end of the season, we do a thorough verification of all the heavy events or not so heavy events or floods or everything. So that because it requires a lot of data handling and a lot of effort. That's what we don't. And in a hurry, we sometimes make mistakes. So that's why we don't present verification at every monsoon discussion. But what VNG said, that I think makes a big sense that we should try to add some mechanism or try to explain why it is happening. If there is evidence why it is happening, just not explain what is not what I am getting in model and showing it. Yeah, thank you, VNG.
No, the verification. Verification doesn't mean that you need to verify all the cases. At least some of the cases.
Yeah, that can be done. few cases is okay.
Reserve everything for the last.
No, few cases okay, but
At least one or two when you discuss, no, then it adds more thought.
yeah, that can be done. Few cases is feasible.
Thank you.
Yeah, thank you.
Thank you for the please come here, sir, so that it will be visible to all. Yeah, okay. Just suppose it is better if we.
Okay, I just had one point. Professor Goswami mentioned that heavy rainfall over Northeast India in June. During that time, it also rained heavily over South China. So probably this Mayu front also had a role in this Northeast monsoon heavy rainfall. I guess.
Is that question to me?
No, it's just a comment.
Comment. I feel they're connected, but not one is the cause of the other. But as I said, the system over Northeast India and South China Sea and Mayu front, that area, the same system is affecting them. Okay, so they are connected in some sense, but I don't think that is the driver. South China Sea has anything to really do. It is the large scale environment which is creating the condition that is conducive for orographically driven rainfall in this region, and that essentially what seems to be what caused the heavy rainfall even in the Northeast. But they as you have seen, that anomaly or the circulation, the cyclonic circulation is affects the both region, the South China Sea and part of China, and then this Mayu front area East Asian monsoon region.
In fact, if you see that June rainfall anomaly map, you can see heavy rainfall from Northeast India through South China, through Korea, Japan. The full belt right here. Yes, Mayu front was also playing like.
Oh,
it's a common thing.
Yeah, they are linked in definitely. They are definitely linked. So
yeah, that's all. Thank you.
Thank you, Dr. Tripadi. Now I want some comment from Professor PNZ. We had excellent discussion so far. The end of June, we are a little concerned because the rainfall was not good. But July is better, excepting the Gangetic plague and Northeast India. So now that August forecast also, as I have seen the CFS, that is the August forecast is also encouraging August and September. I hope that the Northeast India area will be better. One thing we have seen this year, there has not been any break in the monsoon. If there is any break in the August, then there may be a possibility of heavy rainfall over Northeast India. So this is my idea about the Northeast India. And secondly, the new idea presented by Professor Goswami about Northeast India is very encouraging, because I worked there some 40 years back. At the models are not that much developed. We had to depend mainly on synoptic conditions. So it's a very interesting thing we have noticed today.
Thank you.
Thank you, Professor Sam. Julia, you want to comment? Okay, Dr. Gansi.
So first, before making the general comments, first to the seasonal pressure. So I have seen some slides showing the forecast of August and September. So whether scientifically, we can rely on 1 month forecast, because that is based on July incident, right? So how? What? No, he also showed July.
Prediction was July.
Yeah, that's what I'm asking. Say, suppose if you use June IC and predicts for July, how reliable it is scientifically, whether There's such a short range forecast with a couple model.
Skills are or with 4 weeks lead time or 3 weeks lead time.
Okay, so then if you look at the forecast, for example, if you look at the August forecast, so your model is showing mostly positive rainfall anomalies over the western. But if you look at the western belt, if you see, recollect that slide, so only the western side is showing positive anomalies.
Yeah, but you should not go into so much.
That's what I'm asking. No, that is not. That's a. Okay. Okay. Yeah. Then, in all India scale, making a monthly forecast makes any sense? This is a question we should think of. Think about it. Suppose in a season you say all India, it makes some sense. But in a week or in a monthly time scale, if you say I have my model has an all India mean skill, whether it has any message for the public. See, that is the question I wanted to think on that one aspect for seasonal prediction, and in general, concern. First of all, I thank all the presenters. They really work hard to make a good presentation. But if you just recall the last presentation, 29th June, we had a presentation. You know the sort of the feeling we had looking at all the models. We had seen seasonal prediction model, we had seen extended range prediction, short range prediction, all the models we had seen. But the message, what we thought was, we had discussion also. We had several discussions on that, and the July will be very low. That is the message we got from the model. All the models. The July rainfall will be below normal. Okay. But of course, model has its own problem. But the whole model has compared to that. But now, when we present now in the second presentation, when we are comparing with our past forecast, we presented as if the models were very good. See, I'm not questioning the model. I am only questioning ourselves. The feeling we got from the model when they presented last time was very bad. That we all thought that July will be very bad. But now July was good. And now when we compare our model results, we are saying the models did extremely well. But then why we didn't have much confidence in the last presentation? That is one area where we should worry about. Why? What led to that? This is true for all the models. But then in that case, now when we come to August, so what is the actual forecast we are really seeing?
So, sir, there is a missing link. What Dr. Kumarji added. We should have diagnostic things.
Yeah,
then we would have corrected last time also. Okay, we will have rainfall.
Yeah. What, Doctor? Yeah.
Yeah, please.
For the last presentation made on 30th June, Vijit had shown, because if you see Raju's presentation, the first slide he showed was the slide shown by Abhijit. So in that it was clearly shown that in July, the first 2 weeks, it is going to be active. And if you remember, the meso signal, it was very, very large.
Yeah.
And even for verification also, if you see, we have shown, we have not cooked up anything, right? So whatever forecast we had got, the same thing we have shown that time also. Because last presentation is available in YouTube. So in that also, if you remember, the last slide which Abhijit shown was like, for the next 2 weeks, monsoon is going to be active. That was clearly said.
Shall I add something?
Yeah.
I just want to say that what I showed in the last slide, that it was saying for last 2 weeks, it will be likely to be above normal. But later I showed forecast from other center also. That was like NCEP and NCMRW forecast. So first I showed IITM multi-model forecast. There it was indicating that last 2 weeks